Hello guys, task number 3 in your sequence of 9 tasks that will be turned in on Thursday by distance learners on a Google form, 1 through 9 clearly labeled, and those in class will be turning in their binders on Thursday. Each task is sort of short. Task number 3 is the most missed on yesterday's limits and continuity multiple choice set. Now, that doesn't mean that these are the only ones you interact with. You should actually look at any others that you had wrong as well. But these were the 5 most missed problems. Excuse me, I'm getting up from my chair here. So the first most missed was number 4. How many removable? And again, you should just label a blank sheet of paper, number 3, and you should have these 5 problems and their work. All right. How many removable and non-removable discontinuities? Well, for a removable discontinuity, we have cancellation that happens. So the first thing you need to do, excuse me, is factor this denominator to see if we have anything that cancels. And we'll see that x plus 2 cancels. What that means is that x equals -2, there's a hole in the graph and a removable discontinuity. So we have one removable discontinuity. But we also have 2 factors in the denominator that don't cancel. And those indicate that we have asymptotes, vertical asymptotes, at x equals -6 and x equals 3. So we have one removable at x equals -2 and 2 non-removable at x equals -6 and x equals 3. So the answer to that one is D. Number 9, we have a continuous function, f of x. First thing I would do is factor it to get a better idea of what f of x actually is. And I'll notice that f of x is actually the line x plus 1. All right, and again, this is the work you will be showing on your task number 3. It's the line x plus 1. But at 1, there's a hole in the graph, a removable discontinuity. To remove it, f of 1 would have to equal 2. Okay? Next up, it says f, g, and h are continuous. Now, I can understand you getting this one wrong. It's kind of referencing something called the squeeze theorem, which we didn't discuss in a whole lot of details, but we're continuous except at x equals 5. So that's the most important part of it, that at x equals 5, there's not continuity. So it says, which of the following must be false? Because we're not continuous at x equals 5, you don't even really need to read the rest of it. F of 5 can't equal 2, because otherwise we would have continuity there. So it doesn't even really matter what the rest of those say. Kind of a weird problem. This one is interesting. I want to discuss this one because limits are what I call very malleable. They, watch this guy, limit, let's just say as x approaches 2 of 5 to the x minus 1. That's the same as 5 to the limit as x approaches 2 of x minus 1. Just let you absorb that. Notice the limit could go up into the power. Same with, and you don't need to write all this down. When I get to the problem, you do. Suppose I did limit as x approaches 2 of the square root of 4x minus 4. I know you would know to plug that in and say it's the square root of 4, which is 2, but you could have also brought the limit in and under the root and had the exact same answer. So when we have function compositions, like the cosine of f of x, 5 to the x minus 1, the square root of 4x minus 4, where we have functions inside of functions, the limit is malleable. And it can go up into an exponent, it can go under a root. And so what I'm saying is, I'm going to take the cosine of the limit as x approaches 2 of f of x. And the limit as x x approaches 2 of f of x appears to be 0. It says the best estimate. So this is really the cosine of 0. And the cosine of 0 is the x value over here, which is 1. So just kind of know that when you have these compositions of functions, limits are the nicest of our 3 pillars of calculus because constants come out front. The sum of a limit's the limit of the sum, the difference of a limit's the limit of the difference. Same with products. The product of a limit is the limit of the products. There's no quotient rule. It's all just very nice. And for function composition, we can take that function out front and take the limit of the rest, and we'll have the exact same thing. Number 17. If f of 1 is equal to the limit as x approaches 1 from the right. So I have to think about what that means. Okay. So f of 1 is the limit as x approaches 1 from the right-hand side. But f is not continuous. What that means is then as I come in from the left-hand side, I'm not 1. All right, so let's take a look at what this tells me. So it says, which of the following statements must be true? This one doesn't have to be true because I'm not continuous. The limit as x approaches 1 from both directions does not exist. That's got to be true. The reason that's got to be true is because I don't have continuity there. And so if I came in from both sides and the limit from both sides was equal to f of 1, then I'd have continuity. So what that means is as I come in from the left-hand side, I can't be at the same as when I come in from the right-hand side because we don't have continuity at 1. So it should be B, and I believe that's my last one. Awesomeness, it is, right? There's nothing else here. So great, that's it for task number 3.